Implicit differentiation 4. Find the equation of perpendicular line to the curve given by x squared plus xy plus y squared equals 1 at the point 1, 1. Part B. Find the point on the ellipse such that the perpendicular line at 1, 1 crosses the curve a second time. Let's do a bit of review first. d dx of x squared is 2x, that's just a power rule. d dx of y squared is 2y dy dx, that's the chain rule and the power rule. d dx of xy is, derivative of x is 1 times y plus dy dx times x, that's the product rule and chain rule. Perpendicular lines condition, two lines are perpendicular if their slopes are negative reciprocal of one another, if m1 m2 equals negative 1. Or in our case, m perpendicular is equal to negative 1 over m tangent. Alright, let's begin the solution. Apply implicit differentiation to both sides. So derivative of x squared, that's 2x, plus, apply the product rule here. Derivative of x is 1 times y, plus derivative of y is dy dx times x, plus differentiate y squared, that's 2y dy dx. And derivative of a constant, that's just 0. Okay, let's put all the terms that involve dy dx on this side and all the other terms to the right hand side. So we get x dy dx plus 2y dy dx is equal to minus 2x minus y. That's if we bring these two terms to the right hand side. Now let's factor dy dx. We get dy dx times x plus 2y is equal to negative 2x minus y. Divide both sides by x plus 2y and we get dy dx is equal to minus 2x minus y divided by x plus 2y. Now let's first find the slope of the tangent line at 1, 1. So plug x equals 1, y equals 1 into the derivative. We get dy dx is equal to minus 2 minus 1, that's minus 3. 1 plus 2, that will be 3. That's negative 1. That's the slope of the tangent line. Now we're looking for the point at which the perpendicular line crosses the ellipse a second time. So the point that we're looking for is actually this point here. So let's draw that in. That's going to be right there. Okay, so we're looking for this point. Alright, what is the equation of this perpendicular line? We have y minus y1 is m times x minus x1. This is the point slope form. We're going to plug in the slope here. Y minus 1 is equal to, but the slope that we plug in is not negative 1. It's negative reciprocal of this number. So m perpendicular is going to be negative 1 divided by m tangent. But m tangent is negative 1. So m perpendicular is 1. That's 1 times x minus 1. Let's expand this. We get y minus 1 is x minus 1. So we just get y equals x. This is the equation of this line here. Now let's plug this into the ellipse equation and find this point. Okay, so we have y equals x, and we have x squared plus xy plus y squared is equal to 3. Plugging this in, we get x squared plus x squared plus x squared is equal to 3. So we get 3x squared is equal to 3, x squared equals 1, x equals 1, x equals negative 1. Y equals x, we get y equals 1, y equals negative 1. Now, the point 1, 1, we already know about. So the point we're looking for is here, negative 1 and negative 1. And this is the point where the perpendicular line to the tangent line intersects the ellipse a second time. All right, thanks.